Dear students, Namaste, good morning to you all, and also welcome to another session of our mathematics class. In the previous session, we have discussed vector cross product and solved first 5 questions from exercise 10.4. In today's session, we shall discuss the remaining problems from exercise 10.4 and also will solve miscellaneous exercise questions. Let's move on to the topic. Move on to question number 6 from exercise 10.4. The question is given that vector A dot vector B is equal to 0 and vector A cross vector B is equal to 0. What can you conclude about vector A and vector B? Here two statements are given to you. Vector A dot vector B equal to 0 and vector A cross vector B is equal to 0. We have to write conclusions about vector A and vector B. Let's take the first case, that is vector A dot vector B is equal to 0. We know that A dot B, the dot product of two vectors, is a scalar quantity. Here the first option is vector modulus of vector A equal to 0 or modulus of vector B equal to 0. Any one of these two modulus values, if 0 in the sense, A dot B will be 0. That is the first chance. Another chance we have already studied as a property of dot product. That is, first vector is perpendicular to the second vector. Means if two vectors are perpendicular also, their dot product will be 0. So if modulus of A not equal to 0 and modulus of B not equal to 0, then the next chance is vector A is perpendicular to vector B. So here there are two chances arising. The first one is modulus of vector A equal to 0 or modulus of vector B equal to 0. If these things are not happening, then the another option is by using the properties of dot product, we can conclude that vector A is perpendicular to vector B. The next case, if you take vector A cross vector B is equal to 0. Here also the first condition is same, first conclusion is same. The modulus of vector A equal to 0 or modulus of vector B equal to 0. If modulus of A not equal to 0 and modulus of B not equal to 0 in the sense, another option by using the properties of cross product, that we can say that the two vectors are parallel. So in A cross B equal to 0 condition, if you observe, here also two conclusions we are getting. The first one is either modulus of A 0 or modulus of B equal to 0, or the two vectors are parallel. And when you analyze these two conditions together, here comes in the first case vector A is perpendicular to vector B, and in the second case it is coming vector A is parallel to vector B. So A and B cannot be perpendicular and parallel simultaneously. So these two conditions together, it will never satisfy. So our conclusion will be modulus of vector A equal to 0 or modulus of vector B equal to 0. Next we shall discuss question number 7. The question is, let the vectors vector A, vector B, vector C given as a1 I cap plus a2 j cap plus a3 k cap, b1 I cap plus b2 j cap plus b3 k cap, c1 I cap plus c2 j cap plus c3 k cap, then show that vector A cross vector B plus C is equal to vector A cross B plus vector A cross C. Here on the left hand side, if you check, first of all we have to calculate vector B plus vector C. Addition of vectors are very simple. We have to add the components. So here B components, if you check, I components, if you check, B1 and here C1. So B1 plus C1 into I cap, and here it is B2 with J and C2 with J here. So B2 plus C2 into J plus here it is B3 and here it is C3 with K cap. So B3 plus C3 into K cap. So it is written. Then we have to go for A cross B plus C. We have to go for the cross product. So A cross B plus C is equal to, we can use the determinant formula for finding the cross product. I cap, J cap, K cap will come as the first row, and the second row is this first vector components, that is A1, A2, A3. So A1, A2, A3 came as the second row, and B plus C components will come as third row, that is B1 plus C1, B2 plus C2 and B3 plus C3. Let's go for expanding it. I cap into that particular row and column is gone. A2 into B3 plus C3, it's written here, minus A3 into B2 plus C2, it's here. minus j cap into that row and column is gone, a1 into b3 plus c3 minus a3 into b1 plus c1, it's here, plus k cap into that row and column is gone, a1 into b2 plus c2, that is here, minus a2 into b1 plus c1. Then here little bit of expansion we can do inside the brackets, just go for that. I cap into a2 b3 a2 c3, that's here, minus a3 b2, that's here, minus into plus minus a3 c2. Here this minus we can take inside, and here this minus becomes plus. When you take this minus inside, here plus balance, so that plus will be here. Then this minus comes here, means it becomes minus a1. So minus a1 into b3, that is minus a1 b3, minus a1 into c3, that is minus a1 c3, and this minus into this minus, it becomes plus. So plus a3 into b1, that is a3 b1, plus a3 into c1, that is a3 c1, plus k cap into a1 b2, it's here, a1 c2 here, minus a2 b1, that is here, minus into plus, that is minus a2 c1. So this much only the calculation, let it be same. Then we have to go for the right hand side, that is a cross b plus a cross c. First of all we have to go for a cross b. So a cross b is equal to determinant form ijk, components of a vector, that is a1 a2 a3 in the second row, and components of b vector, that is b1 b2 b3 in the third row. Go for expanding it, I cap into that row and column is gone, a2 b3 minus a3 b2, it's here. Then j cap into minus j cap into that particular row, column is gone, a1 b3 minus b1 a3, so it's here. Then plus k cap into that row and column is gone, a1 b2 minus a2 b1, that's here. Then here when you check, I cap is positive, here j cap also positive, k cap also positive, so here j cap is minus. So let's take this minus inside and make it here plus, so that it will be easy for us to calculate at the end. That is, first term remains the same, and this minus comes inside, means this minus becomes plus, that is plus b1 a3, and this plus becomes minus, that is minus a1 b3. So that change will take place here, that is plus b1 a3 minus a1 b3, that's here. The remaining terms are same. Next we have to go for a cross c. A cross c, in the first row ijk, and second row components of a, that is a1 a2 a3, and third row components of c, that is c1 c2 c3. That is just expansion, I cap into that row, column is gone, a2 c3 minus a3 c2, that's here, minus j cap into that particular row, column is gone, a1 c3 minus c1 a3, that is here, plus k cap into that row and column is gone, a1 c2 minus a2 c1, that is here. The same adjustment we can do here also, this minus we can take inside, so that the components I, j and k all will be positive. So here when you take this minus inside, the remaining terms same, I component and k component remains the same, only this one will be changing. This minus comes inside, means this minus a3 c1 becomes plus a3 c1, and this a1 c3 becomes minus a1 c3. Now what we have to do is, right hand side if you check, a cross b plus a cross c. We have calculated a cross b and calculated a cross c, so we have to add these two results. Adding it quite simple here. Here I cap components we have to add, j components we have to add, k components we have to add. That is a cross b plus a cross c is equal to I cap into, you can check here, I cap a2 b3, that is here a2 b3, then a2 c3, the positive values we are writing here. First by seeing this one we can, or simply you can check whether these elements and these elements are same or not, that is enough. Then a2 b3 we have written, then a2 c3 is written, then minus a3 b2 is written, and a3 c2 is also written, plus j cap into b1 a3, then plus a3 c1, then minus a1 b3, then minus a1 c3 is here, plus k cap into a1 b2, then a1 c2 minus a2 b1 minus a2 c1. And when you check a cross b plus a cross c and a cross b plus c, all are same elements. So we can write it as A cross B plus C is equal to A cross B plus A cross C. Hence, proved. Next we shall discuss question number 8. The question is, if either vector A is equal to 0 vector or vector B is equal to 0 vector, then vector A cross vector B is equal to 0 vector. That is a statement. Is the converse true? Justify your answer with an example. Is the converse true in the sense we have to think reverse order. Means if vector A cross vector B equal to 0 in the sense either vector A is equal to 0 vector or vector B is equal to 0 vector. Once again, if vector A cross vector B equal to 0 vector in the sense either vector A must be 0 or vector B must be 0. That is the statement we have to verify. So first of all, let's take vector A, 2I cap plus 3j cap plus 4k cap, and remember when you write vector B, you have to think of this statement vector A cross vector B is equal to 0. Vector A cross vector B is 0 in the sense when you take the determinant, we must get the value 0. See here, determinant, when you think of the determinant of cross product, first row is ijk and second row will be components of this one 2, 3 and 4. And the third row something like this, it must be identical. We have learned by using the properties of determinants, we have learned that if two rows or columns of a determinant are identical, then the value of determinant is 0. So what you can do is simply you can multiply a constant with this vector and we can form the second vector. Then the two rows, when we take a common factor outside, the two rows will be identical, so that determinant will be, value of that determinant will be 0. So vector B is equal to, just I multiply 2 with this one, so 2 into 2 4I cap, then 3 into 2 6j cap, 4 into 2 8k cap. Then let's go for A cross B, ijk 2 3 4 4 6 8. So here if you take 2 outside, this row becomes 2 3 4. So this row and this row are identical, so the value of determinant is 0. But we are not going to calculate by using the properties of determinants. We will just expand it. I cap into row and column is gone, 8 into 3 24, 6 into 4 24, minus j cap into row column is gone, then 16 minus 16, then plus k cap into row column is gone, 12 minus 12, that is equal to 0 I cap plus 0 j cap plus 0 k cap. Then modulus of vector A, we will get it. So here when you check vector A cross vector B, we got a 0 vector here. The first statement is true. Then we have to verify whether vector A equal to 0 vector or vector B equal to 0 vector. For calculating that, we have to check the modulus of vector A, root of x square plus y square plus z square formula, 2 square plus 3 square plus 4 square. We will get the answer as root 29. So since modulus value is root 29, it is not a 0 vector. Then modulus of vector B we can check, that is root of x square plus y square plus z square, 4 square plus 6 square plus 8 square, that is equal to root of 116. We got this also not a 0 vector because magnitude is having a particular value. So we can conclude that the converse of the statement need not be true. Move on to question number 9. The question is, find the area of the triangle with the vertices A112, B235 and C155. So let's draw a rough diagram ABC, and here first of all we will calculate vector AB. So vector AB is equal to 2 points are given to you, that means we can calculate x2 minus x1 formula, that is 2 minus 1 into I cap, 3 minus 1 into j cap, 5 minus 2 into k cap. So I cap plus 2j cap plus 3k cap we have got. Then BC we can calculate. So two adjacent sides we have to calculate. So that's why we are going for BC, vector BC. C minus B, that is 1 minus 2 into I cap. Then 5 minus 3 into j cap plus 5 minus 5 into k cap. So 1 minus 2 is minus 1. So minus I, 5 minus 3 into 2. So 2j cap, this is 0. Then we can use the formula area is equal to 1 by 2 into modulus of vector AB cross vector BC. So what we have to do is we have to calculate vector AB cross vector BC and we have to find out the magnitude of that, and we have to multiply with 1 by 2. So this calculation you will do it as homework. And next question number 10, find the area of a parallelogram whose adjacent sides are determined by the vector A is equal to I cap minus j cap plus 3k cap, and vector B is equal to 2 I cap minus 7j cap plus k cap. We have already learned the formula for finding the area of the parallelogram, and here direct question, adjacent sides vectors are given. So this question also you will try it at home as homework. Next we shall discuss an example question from the textbook, that is example number 26. Write all the unit vectors in xy plane. The answer of this question you have to by heart and keep, and you can use it as a result while solving some questions from the miscellaneous exercise. Here we are asked to write the unit vectors in xy plane. Consider a unit vector A which makes an angle theta with the positive direction of x-axis. Here the general form of vector A is x I cap plus y j cap plus z k cap, and here the unit vector is in xy plane. Xy plane in the sense the z coordinate will be 0. Since the vector in xy plane, there is no z coordinate. So we have also given that vector A makes an angle theta with the x-axis. I have mentioned in the beginning from the diagram. So vector A makes an angle of theta with the x-axis. Angle between vector A and vector I cap is theta. Angle between vector A and I cap is theta. I cap we have already learned before. I cap is the unit vector along the direction of x-axis. First we have assumed that the unit vector is making an angle theta with the positive direction of the x-axis. Now by using that statement we can write angle between vector A and I cap is theta, because I cap is along the direction of x-axis. It is a unit vector along the direction of x-axis. By using the dot product formula, vector A dot vector B is equal to modulus of vector A into modulus of vector B cos theta. Let's substitute. Vector A is vector A only. Second vector we have taken as I cap. So dot I cap is equal to modulus of vector A into modulus of I cap into cos theta. Here this vector A and I cap both are unit vectors. That is vector A dot I cap is equal to modulus of vector A is 1, modulus of the unit vector or the I cap, that is also 1, into cos theta. Then just substitute the general form of that vector, that is xi plus yj plus zk, but z value is not there, z value is 0, because the vector is in xy plane, z value will be 0. So xi cap plus yj cap plus 0 k cap dot this I cap is equal to 1 into cos theta, that is cos theta. Then xi cap plus yj cap plus 0 k cap dot this I cap we can just write it in general form, 1 I cap plus 0 j cap plus 0 k cap is equal to cos theta. That is, when you just take the dot product, x into 1 plus y into 0 plus 0 into 0, because x into 1 I cap into I cap, I dot I, that is 1. So the remaining all the terms will be 0. That is, we will get the answer as x is equal to cos theta. Then the angle between vector A and J is 90 minus theta. From the diagram you can see here angle between x and y, that is 90 degree, and this portion we have taken as theta, and the remaining portion, this portion will be 90 minus theta. So this is J vector, unit vector J means the unit vector along the direction of y-axis, that is J. So angle between vector A and unit vector J is 90 minus theta. Then again using the same formula, A dot B formula, modulus of A, modulus of B cos theta. Then A dot, instead of B we will put the J cap, modulus of A into modulus of J cap into cos 90 minus theta. Then both are unit vectors, their magnitudes are 1 into cos 90 minus theta. That is A dot J is equal to cos 90 minus theta. Then A dot J is equal to, we know that cos 90 minus theta is sin theta. Substitute that general forms, xi plus yj plus 0k, because z value is not there, the vector is in xy plane. Then here only j value will be there, the remaining will be 0. 0 I cap plus 1 j cap plus 0 k cap is equal to sine theta. Then as before, when you calculate how you calculated here, the same way y is equal to we will get as sine theta. Then here vector A is equal to xi plus yj, that is the general form because z value is not there. Then if you substitute it, vector A is equal to x value we have got, x value is cos theta, so cos theta into I cap plus y value we have got, that is sine theta, so sine theta into j cap. So this is the general form of the unit vectors in xy plane, that is vector A is equal to cos theta into I, or simply you can say I cos theta plus sine theta into j, or j sine theta. Move on to the miscellaneous exercise questions. First question, write down a unit vector in xy plane making an angle of 30 degree with the positive direction of x-axis. So this is the question we have discussed just before, the general form of a unit vector in xy plane. That is vector A is equal to cos theta into I plus sine theta into j. So here theta is given to us 30 degree. So that is equal to cos 30 degree into I cap plus sine 30 degree into j cap. Just replace the value, just replace theta and substitute the value, that's all. Cos 30 degree into I cap plus sine 30 degree into j cap. Cos 30 we know it is a root 3 by 2 into I cap plus sine 30 degrees 1 by 2 into j cap. Question number 2. Find the scalar components and magnitude of the vector joining the points p x1 y1 z1 and q x2 y2 z2. It's a very simple and basic question. So the scalar components of the magnitude of the vector joining the points p x1 y1 z1 and q x2 y2 z2. Two things we have to calculate. One is the scalar components and the magnitude of the vector. First of all, we have to write vector pq. We know that x2 minus x1, the second point coordinate minus the first point, that is here itself it is x2 minus x1, then into I cap, then y2 minus y1 into j cap plus z2 minus z1 into k cap. Then from that vector we have to write the scalar components. Scalar components we know that by removing I cap, j cap and k cap, the remaining quantities we have to write by using commas. And next is magnitude of the vector. Magnitude of the vector formula we know, that is root of x square plus y square plus z square. By using that formula, just substitute it. So this question you will try it as homework. Next we shall discuss question number 3. The question is, a girl walks 4 km towards west, then she walks 3 km in a direction 30 degree east of north and stops. Determine the girl's displacement from her initial point of departure. Here there are certain conditions are given to you. We have to go through the condition and visualize it, the given question. Here 4 directions are mentioned, north, south, east, west is marked, and a girl walks 4 km towards west. So the initial point is O, and from O she is walking 4 km towards west, means negative side of the x-axis. If you consider the coordinate system, this is x-axis, this is y-axis, and this is the negative side of the x-axis, and she is moving towards west 4 km, and from A she walks 3 km in a direction 30 degree east of north. So north is straight up from A, and east of north in the sense right side of north. So it goes like this, 30 degree east of north, and she is walking 3 km and reaching at a particular point B and stops. And here if you consider this as y-axis, and this vector AB is making an angle 30 degree with the y-axis, that means the same vector is making an angle 60 degree with the x-axis. So this is the angle we need, theta. So this angle is 60 degree, and we have to calculate vector OB, that is the displacement from the initial point O. From the diagram we can write vector OA is minus 4i, because magnitude is 4 and this is a vector along the negative direction of x-axis, so minus 4i. Then we have learned the general form of a unit vector which is in the xy plane is vector A is equal to cos theta into I plus sine theta into j. This vector is in xy plane, so This is the unit vector formula, that is vector A is equal to cos theta into vector I plus sin theta into vector j. But when you consider here AB, we have to find out the vector AB we have to find out, and vector AB is not a unit vector. There is a particular magnitude is there, that is 3 km, and angle is 60 degree. So cos 60 into I cap we cannot write because there is a magnitude 3 km. So magnitude of AB into I cap we have to write, plus sin theta into magnitude of AB into j cap. So vector AB is equal to I cap into magnitude of AB into cos 60, theta is 60, plus j cap into magnitude of vector AB into sin 60. Then just substitute those values, that is I cap into modulus of AB is 3, cos 60 is 1 by 2, plus j cap into again modulus of AB, that is 3 km length is there, sin 60 is root 3 by 2, that is 3 by 2 into I cap plus 3 root 3 by 2 into j cap. Little bit of calculations or rearrangement. Then vector OB, by using triangular law of vector addition, vector OB is equal to vector OA plus AB. That is written here. Vector OA we have calculated minus 4i, plus vector AB is here calculated and kept 3 by 2 into I cap plus 3 root 3 by 2 into j cap. Just I cap and I cap we can take together, minus 4 plus 3 by 2 into I cap, plus here j cap is 3 root 3 by 2 into j cap, same. Then take 2 as LCM here. When you take 2 LCM, minus 4 into 2, that is minus 8, plus 3 divided by 2 into I cap plus 3 root 3 by 2 into j cap. That is equal to minus 5 by 2 into I cap plus 3 root 3 by 2 into j cap. So this is the girl's displacement from her initial point of departure. Next we shall discuss question number 4. If vector A is equal to vector B plus vector C, then is it true that modulus of vector A is equal to modulus of vector B plus modulus of vector C? Justify your answer. Here consider a triangle PQR and the vectors are marked vector A, vector B and vector C. Here vector A and vector B are co-initial vectors because they are starting from the same initial point, that is P. Here by using triangle law of vector addition, from this triangle we can write vector A is equal to vector B plus vector C. Here we have already learned in the smaller classes that the sum of the two sides of a triangle is always greater than the third side. Means in reverse order, if you say, if you consider one side, the length of one side of a triangle, that will be always less than the sum of the other two sides lengths. That means here modulus of A in the sense that is the length of PR, and modulus of B in the sense length of PQ, and modulus of C in the sense length of QR. So modulus of A means length of the side PR will be always less than the sum of the other two sides lengths. That is modulus of vector A is less than modulus of vector B plus modulus of vector C by triangle inequality law of lengths that you have studied in class 9. Hence it is not true that modulus of A is equal to modulus of B plus modulus of C. Question number 5. Find the value of x for which x into I cap plus j cap plus k cap is a unit vector. Here the modulus of this vector is 1 because this vector is a unit vector. Modulus of x into I cap plus j cap plus k cap is equal to 1. So if you multiply inside x inside, that is x into I plus x into j cap plus x into k cap. So modulus, if you calculate root of x square plus y square plus z square formula. So all the coefficients of I cap, j cap and k cap are x itself. So x square plus x square plus x square, that is equal to 1. That is root of 3x square is equal to 1. That is root 3x. So x square comes out of the root means it will come as x. Root 3 into x is equal to 1 and x is equal to plus or minus 1 by root 3. So that is the value of x. Next we shall discuss question number 6. The question is, find a vector of magnitude 5 units and parallel to the resultant of the vectors. Vector A is equal to 2 I cap plus 3 j cap minus k cap, and vector B is equal to I cap minus 2 j cap plus k cap. Here we have to find out a vector whose magnitude is 5 units and parallel to the resultant of the vectors vector A and vector B. First of all, to find the resultant of the vectors vector A and vector B, in the sense we have to add vector A and vector B. So vector A and vector B adding time, we will get the resultant vector. Then we have to find out the unit vector of vector A plus vector B. Then you will get the parallel unit vector. Then if you multiply that unit vector with 5, you will get the vector or the parallel vector whose magnitude is 5 units. Once again, first of all, we have to find out A plus B, then you will get the resultant vector. Then we have to find out modulus of A plus B. Then modulus of A plus B, after calculating modulus of A plus B, we have to find out the unit vector of A plus B. That time you will get the unit vector which is parallel to A plus B. Then if you multiply that unit vector with 5, you will get the parallel vector whose magnitude is 5 units. So first of all, let's take C is equal to vector A plus vector B. Let's add vector A and vector B. Just components, I components we can add together, J and K components also. Here I component is 2 and J component is 1. So 2 plus 1 into I cap plus here 3 and here minus 2. So 3 minus 2 into J cap. Then again minus 1, here plus 1. So plus minus 1 plus 1 into K cap. When you calculate, 2 plus 1 is 3 I cap, 3 minus 2 is 1 J cap. This term is 0. Then we have to go for modulus of C. Modulus of C means modulus of A plus B. So root of x square plus y square plus z square is the formula. Here z coordinate is not there. So 3 I cap plus j cap. That is root of 3 square plus 1 square. That is equal to root of 9 plus 1. That is equal to 10. Then unit vector C we can calculate. That is vector C divided by modulus of vector C. Vector C we have calculated 3 I cap plus j cap. So 3 I cap plus j cap divided by root 10. Here a vector of magnitude 5 and parallel to the resultant of vector A and B is, as I mentioned before, we have to multiply plus or minus 5 into C cap. That is equal to plus or minus 5 C cap is equal to plus or minus 5 into C cap we have calculated 3I plus j cap divided by root 10. So here root 10 is an irrational number, so let's rationalize by multiplying root 10 in the numerator and denominator. So plus or minus 5 into root 10 by root 10 into this same quantity 1 by root 10 into 3 I cap plus j cap. That is equal to plus or minus 5 into root 10 into 1 is root 10 divided by root 10 into root 10 is 10. So this become rational into 3I plus j cap. That is equal to, just to take this plus or minus 5 inside, that is plus or minus 5 into, here there is a 3 into root 10 into I divided by 10. This plus or minus 5 again multiply with this plus, so it becomes plus or minus 5 into j cap into, here there is a root 10, so 5 root 10 into j cap divided by this 10 also will be coming here. So here 5 and 10 we can cancel 2 times, and here 5 and 10 also we can cancel. So we will get the final answer as plus or minus 3 root 10 into I divided by 2 plus or minus root 10 divided by 2 into j cap. Next we shall discuss question number 7. The question is, if vector A is equal to I cap plus j cap plus k cap and vector B is equal to 2 I cap minus j cap plus 3 k cap and vector C is equal to I cap minus 2 j cap plus k cap. Find a unit vector parallel to the vector 2 into vector A minus vector B plus 3 into vector C. We are asked to calculate a unit vector which is parallel to this vector. First of all, this vector we have to assume as P. So vector P is equal to this one, because this is a little bit lengthier one for easy calculation. So we just assume this one as vector P. Vector P is equal to this vector we have to calculate by substituting vector A, vector B and vector C here. Then we have to go for finding the unit vector. For finding the unit vector, we need modulus of P first. So modulus of P in the sense root of x square plus y square plus z square. By using that formula, we will calculate the modulus of P. Then we have to go for finding unit vector P. That is P cap is equal to vector P by modulus of P. By substituting those values, we will get P cap. So that vector is the unit vector parallel to this one. So this question you will do it as homework. Question number 8. Show that the points A 1 minus 2 minus 8, B 5 0 minus 2 and C 11 3 7 are collinear, and find the ratio in which B divides AC. Here there are two portions. The first part we have to prove the points are collinear, and the second portion we have to find out the ratio in which B divides AC. So first of all, let's take vector AB. Vector AB easily we can calculate the second coefficient minus the second coordinate minus the first one, x2 minus x1, that is 5 minus 1 into I cap, 0 minus minus 2, that is 0 plus 2 into j cap, minus 2 minus minus 8, that is minus 2 plus 8 into k cap. That is equal to 5 minus 1, that is 4 I cap, 0 plus 2, that is 2 j cap, and minus 2 plus 8, that is 6 k cap. Next one we can go for BC. BC means C coordinate minus B coordinate, that is 11 minus 5. 11 minus 5 into I cap, 3 minus 0 into j cap, 7 minus minus 2, that is 7 plus 2 into k cap. Calculation: 11 minus 5 is 6i, 3 minus 0 is 3 into j cap, 7 plus 2 is 9 into k cap. Then we have to go for AC. This one you have to take in cyclic order: AB, BC and AC. Then AC in the sense C coordinate minus A coordinate, that is 11 minus 1 into I cap, then 3 minus minus 2, that is 3 plus 2 into j cap, then 7 minus minus 8, that is 7 plus 8 into k cap. Calculation: that is 11 minus 1 is 10 I cap, 3 plus 2 is 5 j cap, 7 plus 8 is 15 k cap. Then modulus of AB we have to calculate, because for proving the collinearity we have to show that length of AB plus length of BC must be equal to length of AC. So modulus of AB we have to calculate root of x square plus y square plus z square, that is root of 4 square plus 2 square plus 6 square, that is equal to root of 4 square is 16, 2 square is 4 and 6 square is 36. When we add 36 plus 4 40 plus 16 56. 56 we can split as 2 root 14. 56 we can write as 4 into 14. 4 when it come out of the square root, it is 2 root 14. If you feel the mental calculation is difficult, you can go for factorization. Modulus of BC is x square plus y square plus z square root value, that is root of 6 square plus 3 square plus 9 square, that is equal to root of 36 plus 9 plus 81. 9 square is 81. That is equal to 126. 126 we can write as 9 into 14. When 9 comes out of the square root, 3 root 14. Next is modulus of AC, that is root of x square plus y square plus z square, that is root of 10 square plus 5 square plus 15 square, that is equal to 10 square is 100, 5 square is 25, 15 square is 225, that is equal to root of 350 will come. 350 when you factorize, you will get as 5 root 14. 25 into 14 we can write here. When 25 comes out, it comes as 5 root 14. As I said before, if you feel it is difficult to write mentally, then you can go for factorization as rough work, and then from there you can write the final answer here. Then when you observe here 2 root 14, 3 root 14, when you add these two, we will get 5 root 14. That is the magnitude of AC. So we can conclude as modulus of AC is equal to modulus of AB plus modulus of BC. Therefore, the points are collinear. So the first part is over. Now we shall move to second part. Here, find the ratio in which B divides AC. So B is in between AC. So B divides AC in the ratio lambda is to 1. Let us assume the ratio is lambda is to 1. So the section formula we have studied, OR, means the position vector of R is m into b plus n into a divided by m plus n. So m into the second vector plus n into the first vector divided by the ratio we have to add. That is, here we have to go for b divides AC. That means a position vector of b we have to calculate, or we have a position vector of b, that is OB is equal to the first ratio, that is lambda into the second vector, that is OC. The second point is C here. So second position vector is OC plus here n is 1 here. So 1 into the first vector is OA, position vector. So 1 into OA is OA divided by the sum of the ratios, that is m plus n. M plus n is lambda plus 1. Once again, OB, that is the position vector of B, because B is dividing AC. So position vector of B is OB is equal to, by using this formula, first ratio is lambda. So lambda into C, position vector of C, that is OC, plus n into position vector of first one. So n here 1. So 1 into position vector of first one is A. First point is A. So position vector is OA. So 1 into OA is OA divided by sum of that ratios, that is lambda plus 1. That is equal to, here OB we have 5i minus 2k, because here the point B is 5 0 minus 2 and O is 0 0 0 origin. So when you calculate x2 minus x1 formula, here 5 minus 0 is 5i, then 0 minus 0, that is j coordinate is not there, then minus 2 minus 0 is minus 2 k cap is equal to, again OB if you want to calculate separate, we can go for separate calculation, it's not a problem. Once again I will explain OB calculation. The coordinates of O is 0 0 0 and the coordinates of B is 5 0 minus 2. The second one minus first one means 5 minus 0 is 5, so 5 I cap. 0 minus 0, that is 0, so j cap is not there. Then minus 2 minus 0 is minus 2, so minus 2 k cap is equal to lambda into OC. Here we are having OC means C coordinates minus origin coordinates. Origin coordinates 0 0 0. So OC in the sense, here C coordinates 11 minus 0 is 11, so 11i. Then 3 minus 0 is 3, that is 3j. Then 7 minus 0 is 7 k cap plus OA. Here as before, O coordinate 0 0 0, then A is here 1 minus 2 minus 8. Second coordinate minus the first one, that is A coordinate is the second one. 1 minus 0, that is 1, that is I cap. Minus 2 minus 0 is minus 2, so minus 2 j cap. Then minus 8 minus 0, that is minus 8, so minus 8 k cap divided by lambda plus 1 is same. Then go for cross multiplication. Lambda plus 1 will come here. Lambda plus 1 into 5i minus 2k is equal to, here lambda we can multiply inside, 11 into lambda I plus 3 into lambda j plus 7 into lambda k cap plus this one is same, I cap minus 2 j cap minus 8 k cap. Just to go for calculation again, here 5 into lambda plus 1 into I cap. Just removing the bracket, lambda plus 1 if you multiply with the 5 I cap, 5 into lambda plus 1 into I cap, again lambda plus 1 into 2 into k cap, that is 2 into lambda plus 1 into k cap is equal to, here little bit of grouping here, that is here I cap, that means 11 lambda plus 1, if you take out 11 lambda plus 1 into I cap will be coming, plus here j cap coefficient is 3 lambda, here j cap coefficient is minus 2, so 3 lambda minus 2 into j cap, and here k cap if you consider 7 lambda minus 8 into k cap. Then here two vectors are equal in the sense we can just compare their scalar components, that is here I component is 5 lambda plus 1, here I component is 11 lambda plus 1, so 5 into lambda plus 1 is equal to 11 lambda plus 1, that is 5 lambda plus 5 when you remove the bracket is equal to 11 lambda plus 1, that is 11 lambda, this plus 5 lambda going right side means minus 5 lambda, and here one 5 is there, plus 1 coming here means minus 1. So 11 lambda minus 5 lambda when you do, we will get 6 lambda is equal to 4. Then we will get lambda is equal to 4 by 6. After getting 4 by 6, we can cancel 2 there. So it becomes 2 by 3. So lambda value we got 2 by 3. So the ratio is 2:3. Dear students, today we have discussed few questions from exercise 10.4 and also first 8 questions from the miscellaneous exercise. Hope it is clear for you all. If you have any doubt, please note it and keep. We will discuss it during the online session. Thank you for watching.